Watch these circles fit into the gaps. Each new circle touches 3 others exactly. The gaps it leaves get filled the same way. Smaller and smaller circles keep appearing. The gaps never run out. You are looking at one rule, repeated forever. No circle here was placed by hand. Each one is forced by the 3 it touches. This shape is called an Apollonian gasket. But where do these endless circles come from? Here is the plan for these nested circles. First, circles that never stop fitting. They fill every gap with smaller circles. Second, the ancient problem of Apollonius. 3 touching circles allow exactly 2 more. Third, the bend that picks the next circle. A circle's bend is 1 over its radius. Fourth, the hidden whole numbers. Integer bends stay whole forever. Finally, a shape between 2 dimensions. It is more than a line, less than a plane. Now let's see how the gaps keep splitting. Start with 3 circles, each touching the others. A curved triangle of empty space sits between them. Drop 1 circle in, touching all 3. Now there are 3 smaller gaps, not 1. Every new circle makes 3 fresh gaps. Each of those gaps begs for its own circle. The process never reaches an end. Circles shrink toward the edges and corners. A single rule fills the whole space with curves. Now meet the ancient root of this shape. A Greek named Apollonius asked a hard question. Given 3 circles that touch, what else fits? He worked this out over 2,000 years ago. Later, Leibniz imagined filling a region with disks. Here is the rule Apollonius found. Take 3 circles, each touching the other 2. Exactly 2 new circles touch all 3. One nestles in the gap between them. The other wraps around all 3 from outside. Now we need a number for each circle. We use its bend, which is 1 over the radius. A tiny circle has a large bend. A huge circle has a small, gentle bend. The big outer circle even gets a negative bend. So how is the next bend chosen? Descartes found a tidy rule in 1643. Add the 3 bends, then adjust by a square root. That single step gives the next circle's bend. Geometry hands you the answer, no guessing needed. Now for the surprise hiding in the numbers. Start with bends that are whole numbers. Then every circle that follows has a whole bend too. -1, 2, 2, 3, 6, and onward. The fractions simply never appear. Look across the gasket at all the circles. Label each with its bend, and the magic shows. Whole number after whole number, with no gaps. A pure shape quietly counting in integers. Geometry and arithmetic are linked. And finally, what kind of shape is this? Zoom into any gap and more circles wait. The detail keeps going past every screen. Yet the circles never fully cover the space. Tiny holes remain at every possible scale. So we measure it with a fractal dimension. A line counts as 1, a filled plane as 2. This gasket lands at about 1.3. More than a line, but less than a sheet. It lives in the strange space in between. Step back and take in the finished gasket. Every circle obeyed the same touching rule. Every bend came out a whole number. A simple idea grew into endless structure. Beauty, history, and arithmetic in one shape. So what do these circles leave us with? One rule about touching, repeated without end. It fills a plane yet never quite closes it. And it hides whole numbers in plain sight. Simple rules keep their secrets quiet.